Stop what you're doing right now. If you thought the universe couldn't get any weirder, the James Webb Space Telescope just said, "Hold my beer." It's December 2025 and NASA just dropped data confirming a world that absolutely defies cosmic logic. We aren't talking about a slightly quirky planet, we are talking about a world where gravity is so violent it physically grabbed the planet and stretched it into the shape of a lemon. Meet PSR J23222650b, the most extreme exoplanet we have ever seen. Now, space nerds who have been following the news for a while might say, wait a minute, we didn't already find a stretched out planet a few years ago? You're right, you're thinking of the WASP 103b. Back in roughly 2022, we were amazed by WASP-103b. It orbits a regular star a bit bigger than our Sun. In less than a day, that proximity caused what scientists called significant tidal deformation, stretching it into the shape of a rugby ball. At that time, we thought that was extreme. WASP-103b was a gentle stretch. PSR J23222650b is a cosmic torture rack because the new guy, it doesn't orbit a normal living star. It orbits a zombie, a pulsar, a hyper-dense, rapidly spinning corpse of massive star that went supernova. And the gravity near a pulsar isn't just strong, it's sicking. JWST data confirms that this planet is being pulled so hard at its equator that it's bulging out into pointy ends at the poles. It is literal the planet-sized lemon whipping around a dead star. But here is the thing, the shape isn't even the weirdest part. The weirdest part is what's happening inside those stretched out clouds. Before we get to the nightmare atmosphere, we have to understand the stretch. How do you turn a spear into a citrus fruit? It all comes down to tidal force. We know the tides here on Earth. The moon has gravity, it pulls on the Earth. But because gravity gets weaker with distance, the moon pulls harder on the side of the Earth facing it than the side facing away. This difference in pulling power stretches the water, creates high tides, but Earth is rocky and far away, so the planet itself doesn't stretch much. Now, take the concept and dial it to roughly 11 billion. Pulsars are incredibly compact. Imagine stuffing twice the mass of an entire sun into a ball the size of Manhattan. The gravity field changes drastically over very short distances. PSR J23222650b is orbiting terribly close to this monster. This means the gravitational pull on the nose of the planet facing the pulsar is unbelievably stronger than the pull on the back of the planet. Think of the planet like a ball of pizza dough. If I just hold it, it stays roundish. But if I grab one side and pull incredibly hard while someone else pulls the other side just a little bit, it stretches. This planet is living on the edge of what we call the Roche limit. That's the theoretical line where the difference in gravitational pull becomes stronger than the gravity holding the planet together. Cross that line, the planet doesn't just stretch, it gets ripped into a ring of dust. The lemon planet is currently flirting with disaster, being stretched into its absolute limit without quite breaking apart yet. So we have a lemon-shaped world whipping around a dead star that's already a top-tier weird exoplanet. But the recent spectroscopy data from the JWST has added a twist to that astronomers are calling the Exolodem. When the JWST analyzed the light filtering through its stretched atmosphere, it didn't find water vapor or silicate rock clouds like we usually see. It found carbon, an unimaginable amount of carbon. The atmosphere is essentially thick black soot. Because the planet is being squeezed and stretched so violently by tidal forces, the internal heat is off the charts. You combine intense heat, crushing pressure, and pure carbon atmosphere, and you get something spectacular. We suspect it rains diamonds on Neptune and Uranus deep inside, but on PSR J2322-2650b, it's not a diesel, it's a monsoon. Scientists believe great diamond hailstones are forming on the upper atmosphere and raining down into a deep liquid carbon ocean, all while the entire planet is like a piece of fruit. And this leads us to the final terrifying question: why does this planet exist? Remember, it orbits a pulsar. Pulsars are born in supernova, the most violent explosion in the universe. When the original star died, the blast should have vaporized any planet nearby. If it survived the blast, the subsequent expansion of the star should have swallowed it. If it formed after the explosion out of the leftover debris ring, well, current models say there shouldn't have been enough heavy materials left to build a giant planet, let alone one made almost entirely of carbon. The lemon planet rules out every single planetary formation mechanism we currently have. It is a diamond raining, lemon-shaped impossibly that survived a supernova. The James Webb Space Telescope didn't just find a new planet this month, it found a massive hole in our understanding of the universe. What do you guys think? How did the lemon planet survive? Let me know your wildest theories down in the comments. If you want to keep up with this story as we analyze this data into 2026, make sure you hit that subscribe button. Stay curious and thanks for watching.